Time is brain. Every minute, millions of brain cells die.
It's so difficult to predict how any one patient will suffer from being mistriaged.
My mother passed away about 4 years ago, and she died of a massive stroke.
We don't have anything right now. If somebody's got a hemorrhagic bleeding in the brain, the only way I can tell if anything's going on, or if they're getting worse in particular, is they get sleepier or their neurologic exam changes.
When the EMTs came to pick her up, they knew that that was probably what was going on. They took her to the closest hospital, but the closest hospital was ill-prepared to deal with the extent of the stroke that she was having.
And then by the time you figure out that something's getting worse, you're behind the 8 ball.
15 minutes away from the hospital that they took her to is a comprehensive stroke center. Now, they could have taken her directly there. They thought they were doing the right thing, bringing her to the closest hospital for treatment, but that hospital was ill-prepared to give her the kind of treatment that she needed.
And that's not a rare occurrence. That's a fairly frequent occurrence, particularly in a busy ICU or a busy emergency department.
Chip Shaw and I and a couple of other colleagues scratched this thing on the back of a napkin.
And we got into this discussion about, well, what do you need to take care of brain-injured patients? And all 3 of them said, we want a non-invasive monitor of the brain.
So it was a cohesive effort to try and figure out this problem. We had all identified it and wanted to come up with a means of addressing it.
Everyone that's been involved in this have been involved in other startup companies, and I know them personally and know their capabilities. I got a big check mark on the team, which is my primary method for selecting investments in startup companies.
The quick catchphrase is radar for the brain. What the device does is we have an array of antennae, it's 9 antennae, and we pick that number to optimize, make sure that we're seeing all regions of the brain, including the deeper parts of the brain.
So if there is a expansion of any bleeding in the brain, we're going to pick it up in real time. We can detect a bleed as small as 1 milliliter, which is basically the size of a pea.
I like the idea of it being non-invasive and a simple test that can be done by a first responder. I mean, it's that simple.
Yes, if Sense was available at the time, they would have been able to determine that she in fact was having an intracranial bleed, in which case they would have rushed her, I'm sure, to the Comprehensive Stroke Center.
I mean, this isn't myth or conjecture. It's all been proven in the clinical and in the animal studies. So I think those were the key things that I believe made this a real good opportunity for me, and why it checked all my boxes. And there's always been the concern about a new technology going into the marketplace. But all of those in the past didn't have any clinical data to deal with it.
I really need this device, and I'm not I'm speaking for my entire specialty. If you're an ER doc practicing in a busy level 1 trauma center or a busy neurocritical care hospital, you need this. I know it. I needed it.
I think it's the right thing to do for the society in general and the world.
Somebody's got to do it. I think we can.